Yes, good morning, friends. Once again, welcome to the session. Okay, I hope you all are doing good. How is your preparations going on? A very warm welcome to all of you. Yes, I hope my audio and video is working fine. A very warm welcome once again. As you know, since I cannot see myself in the screen, I hope my audio and video is also working fine. And also, in the middle of discussion, if you have any doubt, the only interactive model is you have to signal me in the live chat below. Okay, so if you are not following any point, any topic, don't hesitate to send me a text. You can interrupt me at any time in the live chat below. Okay, anyways, today is the sixth session. Hold on. Today, okay, sorry. Today is the sixth session, okay, sixth session under our climatology. We are discussing climatology. So in climatology, we have already discussed what is the composition of atmosphere, what is the structure of the atmosphere we have seen, and also we have seen the basic characteristics of temperature and insolation, and in how different location of the earth, different types of temperature, insolation, temperature belt, isotherm. Similarly, we have also seen the pressure belt of the world, the shifting of different pressure belt, and with the play of this temperature and pressure, how different cells are developed, taking care into consideration the vertical circulation also. Therefore, we have seen the tricellular meridional circulation like the Hartley cell, the Ferrel cell, and the polar cell. Clear? Now, after this, we have seen how the interplay of temperature and pressure give rise to different wind system. The entire wind on the planet Earth can be broadly classified into three. One is the planetary wind. We have seen we have the seasonal wind or the secondary wind system, such as tropical cyclone, so on and so forth, which we will deal after some time. Okay, and after that we have seen the local wind. Local wind happening in a localized area because of some local factor. Under this local wind system, we have already discussed, under this local wind system, we have already discussed the land breeze and the sea breeze. Also, we have seen katabatic wind and anabatic wind, which is the valley and the mountain wind. Okay, valley breeze and the mountain breeze we have already seen in the last class. Today we will begin with different types of hot wind and cold wind. Regarding this land breeze, sea breeze, valley and the mountain breeze, they all are kind of general, but other local winds can be broadly classified into two, that is hot local wind and cold local wind, which we will see today. If time permits, we will also see one important phenomena, that is the origin of this jet stream, okay, which is a very, very important upper air circulation. Clear? But before going into the session, I have some important information to make from the Unacademy platform. That is, you see, Unacademy comes up with, depending on whether it is a prelims or mains exam, Unacademy always comes up with some courses. Okay, now, in the last year, Unacademy come up with this Unacademy's last mile connection. Now, last mile program. In this particular course, many of the successful candidates took part. Say for example, all Indian rank 1 to 20, 7 learners were there. 20 learners from this last mile program was able to secure all India rank 21 to 100. Similarly, 143 learners secured rank from 101 to 761. So you kindly subscribe to this if you haven't, plus combo course, okay, which is there in the Unacademy. Expected another price rise on 16th of December, very soon, only some 2-3 days left. After that, some mega price hike will be there very soon. So before this mega price hike, kindly take the advantage of this window of opportunity. and kindly subscribe to this plus combo. Okay. Similarly, you have this plus GS. So kindly subscribe. If at all you require any code, you can use my invite code, that is SUNEP10. Okay. You have this iconic subscription where you can level up your UPSC preparation also. Okay, you will get one-to-one live mentoring. Okay, like a personalized coach. You will have this study planner, and also you will have this mains question and answer writing practice session. Clear? Chalo. With that, let us quickly go ahead with our point of discussion of today. That is hot local wind. As I have mentioned just now, the local wind can be broadly classified into two: hot local wind and cold local wind. Now the local wind which we have seen in the last class regarding the mountain and the valley breeze and also land and sea breeze, they are kind of a local wind, but they are kind of a very generalized in characteristics. Okay, but other local winds can be broadly classified into hot and cold local wind. There are many local winds. Okay, there are many local winds, but we will take up some important ones. Okay, now you see here, the first hot local wind that we will take is known as fawn. Now where this particular local winds occurs, it occurs in the lee side of the Alps mountain system in the southern Europe, mainly in the Switzerland area, Germany, and also it occurs mainly during the winter season. The location is this one, you see here. This is a Alps mountain range. On the lee side, in a sense, when the wind blows in this direction, the lee becomes this side. So in Switzerland, Germany, all of this region, this particular local wind known as fawn local wind you will find. It is a hot local wind, but remember, the hot and cold local wind is decided based on the relative temperature of this wind, not the absolute temperature of this wind. Okay, you see here. In this site, particularly during the winter, the local wind like the fawn wind may also be, in absolute term, temperature will be not much. But compared to the surrounding area, the air in the surrounding area, this particular temperature of temperature of this particular wind is much higher. Means the relative. It is not the absolute value of temperature, okay, which is used in characterizing or categorizing whether it is a hot or a cold. It all depends on the relative temperature with the rest of the surrounding. Now you see here. As you know, this particular location will come under subtropical high, okay, subtropical high pressure regions. Around this region, you cannot say exactly at one specific point, but around this region, there are upper air subsidence. In low pressure cell, vertical motion is upward. Wind moves upward. In subtropical high pressure area, wind subsides down like this. Okay, now, the wind which is subsiding like this, it can be from other source also. But the wind which is subsiding, air which is subsiding like this, when it blows in this direction, this is the windward direction. Now, the wind which is subsiding below moves up like this in this direction. It moves up the hill, these Alps mountain ranges. On the other side, it subsides below like this. We know the basic principle. Whenever air moves up, it cools down. Okay, cools down. Whenever wind comes down, it heats up. Temperature increases. Okay, two very basic principles. Therefore, this particular wind which is moving up in this direction, on the lee side of the mountain, it will subside below. During the process of subsiding, the temperature increases. When the temperature increases, it brings warm condition to this particular area. Now, the contrast of the temperature, as I have already mentioned to you, the hot and cold is not depending on the absolute temperature but relative. It is mainly effective in the winter season. Why? Because during the winter season, you see, in the continental Europe, it will be very cold. Okay, now, therefore, this local wind brings warm condition into this particular region, on the lee side of the Alps mountain region. The intensity of this particular foehn wind system is, you see here, foehn wind can raise the temperature by as much as 14 degrees centigrade in just a matter of hours. Switzerland area, southern Germany, Austria have a warmer climate due to this foehn wind, as moist wind of the Mediterranean Sea blow over the Alps region. Now, one of the benefit is it clears the area for cultivation. Why? Because melting of ice will take place, and also it results in opening new areas for cultivation. Clear? So that is one of the advantage of this hot wind. Why? Because the area out here is very, very cold. That is one positive, but there is also a negative aspect of this. Another positive aspect can be the climatic condition become very mild. Okay, therefore it brings comfort to the human settlement also. Why? Because you see, in this region it is a very, very cold, especially during the winter. So when a hot wind comes like this, it raises up the temperature of the atmosphere, so brings comfort to the people. But there is a negative impact also. There are some, see, crop or fruits. All different crops, different fruits have different condition. It requires different soil condition. It requires different temperature. Now, there are some crops and agricultural crops and fruits or trees, plantation, which is grown or which requires a very cold temperature. Now, in this time of the year, if a warm wind comes like this, it may destroy the winter crop. So that is one negative impact. Clear? So we have seen both the positive as well as the negative impact of this foehn local wind. Its locations. The second type of hot local wind is Chinook. Very similar mechanism is very similar as that of the foehn wind. You see here, in the United States, you see, you watch this diagram. This is a United States in the northern America. Here the mountain system is like this, the Rocky Mountain. Okay. Now, because of this, from the Pacific Ocean side, whenever a wind is blowing like this, it comes up the mountain range on the western side. And after reaching this place, the wind will have to come down. When the wind comes down, we know when the wind comes down or subside below, it warms up. Therefore, because of warming, it brings on the eastern side of the Rocky Mountain in the North America, okay, in the northern, in the United States region, it brings a warm wind, which is known as hot local wind, which is known as Chinook. It also, one positive aspect is, it melts the eye and leave behind region or opening up of region, okay, which is available for cultivation as well as for the pasture. Clear? It is also known as snow eater. Why? Because this hot wind melts away the ice which is in this particular location. Clear? That is known as Chinook. Okay, it is in North America. Third type of local wind is Santa Ana. Now you see here, Santa Ana at the high altitude, okay, of mountain ranges in a Great Basin and surrounding area, a cold wind is there. Now, because it is at a higher altitude, that's why the nature of the wind is cold, but it subsides downward like this. You see, when it subsides down, what will be the characteristics? Since this wind originates from the mountain ranges up, it will be dry wind, and also while coming down, it will have to heat up. Therefore, this is also a warm or hot local wind. Now, the significance of this is, you will find, you must have heard in the news regarding forest fire in California and all of this region. This is also one way or triggering of forest, natural forest fire. Now, when this wind comes, hot wind, when the leaf is dry, okay, this creates a trigger in order to activate or initiate the forest fire in this particular region. Clear? This is known as Santa Ana. Clear? See, dry leaf, dust, all of this. Okay, now, fourth type of local wind is known as Sirocco. Similar type of a wind you will find in Australia on the northern side. In Australia, similar type of a hot local wind is known as brick fielder. Okay, the name is important. Now, from where and how this local wind is blowing, you see here. Over the Mediterranean region, a low pressure develops and the wind blows away from the interior of the northern African region, from the Sahara desert margins, blows towards the Mediterranean region in this manner. And you remember, there is also a high pressure area, subtropical. Now, whenever a wind blows like this, you see, the wind is blowing away from a desert or an arid or a semi-arid region. That's why this particular wind will be very dry and also at the same time consists of very dusty, okay, very dusty, sand-laden wind also you can see. In real life, you see here, this is the real life picture of Sirocco. Sirocco comes in this manner, you see here, because it is blowing from the interior, from a arid and semi-arid region. It is blowing towards the Mediterranean Sea. When it crosses this particular Mediterranean region, since it is over a water body, moisture is taken up by this wind. Once the moisture is taken, when it hits the southern coast of Europe, a rain is given out. And this rain is also known as red rain, or you can say, I think, blood rain, if I'm not mistaken. Blood rain. Why? Because it is red in color because of the sand-laden wind. Okay, clear? That is known as Sirocco. The fifth type of hot local wind is Kamsen. Kamsen is a local wind which is blown from the Egypt side like this, in this manner. Okay, Sirocco in this side, Kamsen in this side. Now the basic difference is because of the mechanism with which they are triggered. Clear? If you are interested, you can go and read. The sixth type of local wind is known as Harmatan. Harmatan is blown from the interior location like this. See, this is intertropical convergence zone. I am not explaining about this further. Why? Because we have already discussed this regarding shifting of pressure belt. And during the shifting of pressure belt, we have seen two. That is, one is the idealized one. Okay. But in the real world, because of differential distribution of land and water, how the actual shifting of the pressure belt is taking place, we have already discussed in the last class. But whatever the reason it may be, this is a intertropical convergence zone which is shifting like this, and the wind blows away from the interior towards the water body like this. This is known as Harmatan, a local wind. Okay, that completes our hot local wind. You see here, there are many other hot local winds. Okay, we have taken the most important ones. Now, at least you need to study what we have just discussed. Minimum. Okay, you can add more. Okay, you can add more, but at least this much you will have to study. Okay, then let us now quickly go to the cold local wind. What is this cold local wind? The first one is Mistral. Mistral is a cold local wind during the winter, especially from the interior of the Europe, southern Europe, especially from the France region. This, you see here, in the winter, this continental, this is, Spain. Okay, Portugal will be here, Spain. Okay, this is France. Now, from this region, this is a landmass. During winter season, a high pressure is developed in this particular continental region. High pressure in a sense, I can say very cold. Okay, hot means low pressure, cold means high pressure. So during winter, it will be very, very cold in this continent. Okay, now Cold means high pressure. Now this is a Mediterranean Sea. On water body, because of specific heat, it warms and cools slowly as compared to the land. So this will be warmer. It is very cold. Therefore, a wind will blow like this. This is a Mistral wind. And it is a cold wind. Why? Because coming from the continental part, which is very, very cold. And this is also more severe during the winter time, when the temperature contrast is maximum. Next type of cold local wind is Bora. Bora. You see here. B-O-R-A. Now, you see, the Alps mountain ranges, which runs from southeastern side of France and northwestern side of Italy, which is running like this, okay, comes to this region, Croatia, Hungary, okay, this is known as extension, it is known as Dinaric Alps. Now, from these particular mountain ranges, a wind comes down like this. On this side, see, this is the Alps mountain ranges like this, okay, it is known as Dinaric Alps. On this side, the wind comes down like this from the interior location like this. It debounces into this Adriatic Sea. Now you tell me one point, okay, now you tell me one point. You see here, this is Italy, okay, Dinaric Alps is here, okay, this is Adriatic Sea. Now you tell me, just now in 2-3 condition, like say for example, the Chinook, which is in North America, okay, and also the Fawn wind in the Alps region, we have seen that the wind comes down and becomes warm. Okay, therefore they were categorized as a hot local wind. Now you tell me here, this wind is also coming down the mountain, which means when a wind comes down, it heats up or warms up. Therefore, why it is categorized as a cold local wind? Why not it is hot? The reason is very simple, as I told you just now. This warm or cold local wind is not based on the absolute temperature, but it is all relative. Now, yes, this wind which is coming down, it will warm up, no doubt. That basic principle will follow. But when you compare this particular temperature, okay, temperature of this particular wind and this particular temperature over this Adriatic Sea, okay, the wind condition, this particular air temperature is much cooler as compared to the environment here in the Adriatic Sea region. That's why they are categorized as a cold local wind, and it is known as Bora. The third one is blizzard. What is this blizzard? Blizzard is a snow laden wind. Now, say for example in the North American region, this is a Great Lake region, okay, this is Canada, this is America. Now you see here, the mountain ranges are oriented like this. If you come, means from north to south or from south to north. Now if you look at the Alps mountain ranges and the Himalayan mountain ranges, they are oriented east to west or east to west or west to east in this manner. Therefore, say for example India, if the Himalaya was not there, or if the orientation of Himalaya is not east to west or west to east like this, then a very cold wind from the interior like from the Siberian region and all, would have come to a much larger extent in the south, even in India. But because of the orientation of the mountain range, it is blocked. But here in the American region, you see, orientation of the mountain is like this. Therefore, from the interior location or from the polar location, a very cold and snow-laden wind can come to the south much further like this. Such type of a wind is known as blizzard. In real life, you will find like this. The visibility is also reduced to a very larger extent. Clear? These are different local winds. Okay, so you kindly go through. If you can catch hold of some 2-3 more local winds, cold and warm, hot local wind, that will be much better. Clear? Let us quickly go to one important concept Okay, one very important concept, that is the origination or the formation of jet stream. Okay, jet stream. Now, jet stream for upper air circulation, jet stream is very important. In order to understand the Indian monsoon properly, again, the knowledge about jet stream is very important. You see here, whenever you are discussing climate, whenever you are studying climate, what you are studying? You are studying the atmosphere. Now, atmosphere has a height component also. Therefore, while dealing with climatology, you are not dealing with the phenomena, means the wind system, the temperature or circulation, not only on the ground surface. You take the vertical component also. Now, jet stream is such a wind system which you will find up high in the atmosphere. And now, the upper air circulation and the lower air circulation, which is on the ground surface, they are interrelated to each other. The upper air circulation determines the air circulation on the ground surface also. You see here, that's why during our discussion of low pressure belt in the equatorial region, high pressure in the polar region, which are thermally induced, we have already seen, but subtropical high in 30° north latitude, polar low in 60° latitude north, those two pressure belt, one is high subtropical, polar low, they are not thermally activated. They are dynamically formed. And why dynamically? How? Because of upper air circulation. Clear? Now, therefore, in order to understand the subject, that is climatology, the atmosphere, it is very important to know the upper air circulation. There are many upper air circulation, but one of the important upper air circulation is the jet stream. Why the name jet stream is called? Why? Because this particular jet stream is discovered by fighter jet pilots, okay, especially in the Second World War. This wind blows from west to east like this in the upper atmosphere. Therefore, when a fighter jet was blowing from east to west in this direction, it takes longer time. Okay, it takes longer time to reach from one place to the other. Why? Because the opposing headwind in the form of jet stream is blocking this one. On the other hand, with similar speed, while traveling from west to east like this, it took less time to reach this place. Even though inside the jet stream, inside the fighter jet, they maintain the same velocity. Means while traveling from west to east like this, the fighter jet is pushing by this wind system. That's why it is known as jet stream. Now let us see how they are originated. Okay, in order to know that, you kindly follow the pointer. Okay, it is very easy, but you need to understand. Clear? Now, you see here, kindly follow the pointer. Okay, you see here. Let me consider this as a polar region and this as a equatorial region. Now you know the height of the troposphere. The height of the troposphere is around 16 km in the equatorial region. Okay, the height of troposphere is only around 5 to 10 km over the polar region. Clear? Now, you see, it is very warm in the equatorial region, very cold in the polar region. In the equatorial region, you have low pressure. In polar region, you have high pressure. Clear? Now, if I go up, it cools down. Okay, in the equatorial region, if I go up, the cooling is very less. The rate of cooling is slow in the equatorial region. On the other hand, in the polar region, the moment I go up, the cooling happens rapidly. Why? Because it is very cold here. In the equatorial region, it is very warm here. Therefore, and also the sun is near the equatorial region. Therefore, it is very warm. Therefore, the cooling now, You know the basic relationship between temperature and pressure. Warm temperature results in low pressure. Cold temperature results in high pressure. Now, reduction of pressure will take place here, which means the moment I go away from the surface, okay, temperature reduces. Okay, now also another important point is the density of the atmosphere is maximum on the ground surface. Okay, pressure is maximum. Now you see here the average air pressure, okay, the average atmospheric pressure, standard pressure we consider in the sea level. Okay, the moment I go up, the column of what is air pressure after all? The column of air above the ground surface which is exerting on the region, it is considered as a pressure of this particular place. At the sea level, let us consider a same air pressure over the polar region as well as over the equatorial region, because it is the same column of the air which is acting against this particular surface. The moment I go up, the height of the column reduces, so pressure reduces. Therefore, the pressure is less in the mountainous region. Now, the rate of change of this pressure is much slower in the equatorial region, but in polar region it is very high because it is very cold. Now you see here. Therefore, if I take maximum pressure on the ground surface and if I go, say for example, I will reduce it. Say for example, it is around 1000 millibar in the ground surface. Here also 1000 millibar and the surface level. I will reduce it now to 900 millibar. I go up 800 millibar, okay, 700 millibar, like this. Now, over the polar region, you see here, the height of troposphere here is 16 kilometers. Here is only 7 to 8 or 10 kilometers. The reduction in the pressure will be much faster, which means 1000 millibar on the ground surface. If I go up, say for example, 900 millibar, if I go up further, 800 millibar, if I go up 700 millibar. Clear? Till this, is it clear? Now, you tell me, you forget everything, but you just let me take one particular height, okay, one height. Let me take one horizontal height like this. Now, at this particular horizontal height, you kindly see the pressure. Here over the equatorial region, the pressure is somewhere around 900 millibar here. But at the same height over the polar region, the pressure is how much? Below 800. Similarly, you come to this height. In this height, the air pressure over the equatorial region is somewhere around 800 millibar. These are just example numbers that we are taking. These numerical figures 800, 900, these are just for example. But here you come here, it is less than 700 millibar. Now, what is the basic idea of flow of air? The air blows from high pressure to low pressure. Now, at this particular height, okay, similar height I am taking. You see here, at this particular height, what is the pressure here over the equatorial region? 900 millibar. What is the air pressure over the polar region? It is less than 800. Which one is higher? This is higher. So what will be the direction of the flow of the wind? The direction of the flow of the wind will be from equatorial region to polar region in this direction at this particular height. Is it clear? Is it clear? Now you see. We also know there is a concept known as Coriolis force. Now this Coriolis force acts on all the moving object. So this particular wind system also will come under the influence of Coriolis force. Therefore, I will give you the top view. Say for example, here is the equatorial region, polar region. This wind is blowing from equatorial to polar region like this, but it will come under the influence of Coriolis force. Therefore, it will be tracked towards the right like this. It will continuously track until it becomes geostrophic wind. Remember, geostrophic wind. We have already seen what is the pressure gradient force and what is the geostrophic wind. A geostrophic wind is a wind which blows parallel to the isobar, which means, you see here, after reaching this particular direction, it is not going to curve any further. Okay, it will blow in this. That is geostrophic wind. Now, so this particular wind system, which is blowing because of difference in the pressure at this height from equatorial region to the polar region, will be curved into like this. Now, this particular wind is known as a thermal wind and is nothing but the how the jet streams are originated. Clear? You see here. At the polar region, at the equatorial region, the placing of this pressure vertically is like this. See, it is reducing very gradually here over the equatorial area. Why? Because very warm here. But over the polar region, it is reducing very fast. Therefore, if I draw a horizontal line like this, then the pressure here will be much less as compared to pressure here. Therefore, the wind is activated, but the Coriolis force come into being and it is diverted like this. And this is how a jet stream is developed. You see here. And this is how a jet stream will look like. Any doubt regarding any point? Kindly go ahead and ask me. This is how a jet stream is developed. There are many different types of jet stream, but two very important jet stream is subtropical jet stream, which you will find around this region. This is equator, this is North Pole, 30 degree, 60 degree latitude. We have different cell here, Hadley cell, Ferrel cell, all those. Okay, and this is how. This is known as, this particular jet stream is over the subtropical region. That's why it is known as subtropical jet. Another jet stream you will find here, that is polar jet stream, polar front jet. Okay, and now the movement of this jet stream is, it meanders. We know the meandering of the river. So it meanders around the globe like this. So the tropical jet stream meanders like this. Polar front jet stream meanders like this around the globe like this. Blows from west to east in this manner. Now, this jet stream, okay, is important for our climatology. Why? Because this upper air circulation determines or influences the ground level circulation also. See, one form of, you see here, heat or thermal induce high pressure, low pressure. Okay, if it is warm, then low pressure. If it is cold, high pressure. That is one. But as we have already seen, there are certain high pressure and low pressure on the ground surface which cannot be explained thermally but by the dynamic process. Now, jet stream, the flow of jet stream on the upper air also results or also influences some ground high and low pressure cell. How it is? You see here. The nature of movement of jet stream is like this. I told you just now, it meanders. Remember, this is a ground, this is a upper air circulation. Okay, upper air circulation. Remember, whenever a jet stream is meandering like this, the wind velocity on this direction is on a ridge. Okay, this is a ridge, it is a trough. Okay, imagine like this. So on the ridge side of this jet stream, the velocity of the wind is very fast. On the other side, the velocity on this side is slower. Now you see here, one wind is coming very fast now to this particular region, but the velocity of the wind on this side is slow. Means more input, you can imagine, less output is taking place from this side. Therefore, what will be the result? There will be staking of the wind or air over this. Okay, on this side there will be staking of air. Now, when a staking of air will take place, what will be the ultimate location to which it will flow? It will have to subside below. Okay, subside below. Therefore, it will come down on the ground surface. When it comes down to the ground surface, where is the ultimate direction that the wind will go? It will go away from the away in all the possible direction on the ground surface. Means on the ground surface it will flow away from this region where the air is subsiding. And what is this nature? Away from one location, from high pressure area. From high pressure area, wind blows out in all the possible direction. Clear? Now, therefore, anticyclonic circulation, you will find anticyclonic circulation, okay, like this, over a ridge. That is jet stream. On the other hand, you see here, on this side, see, on this side, high velocity means moving away, taking the wind away, high velocity. On this side, a very slow velocity of the wind is very slow, which means a vacuum is created here in the upper air. When a vacuum is created, what will happen? Some air needs to be flown into that area so that the vacuum is filled up. Now, because of this is a upper air circulation. In order to fill this particular vacuum, because of differential in the velocity of this jet stream, on one side it is faster, it is slow vacuum. From below, the wind has to come up. From below ground surface, when a wind is going up, it has to first come from all the possible direction in the ground surface. Only then it will be able to go up and fill this place, which means over the trough in the jet stream, okay, below you will find low pressure. Low pressure is wind comes from all the possible direction. So that is how the movement of jet stream influences the ground situation also. Certain high pressure and low pressure, or you can say certain cyclonic, anticyclonic. This can be a cyclonic circulation, this can be anticyclonic circulation on the ground surface. Clear? I hope that is clear. Okay, we'll end the session here today. We will continue tomorrow at the same time. Okay, so if you have any doubt, any query, feel free to revert back to me tomorrow. We will have the session at the same time, 11 to 11:40. Okay, anyways, thank you so much for your patience and cooperations. We will continue our discussion with some of the important concepts again regarding adiabatic heating and cooling.